Greetings to everyone, and welcome to Omicron IoT Solutions. Today, we will show you how to read a sensor using the Modbus RTU communication protocol and send the data to the cloud using LoRaWAN technology. For this example, we will use a radar distance sensor, which is connected to the ContraLog Mini through the RS485 standard-enabled ports and powered with 24 volts. For practical purposes, we will connect and power the ContraLog Mini through the USB Type-C port in order to check the values read by the sensor through the serial monitor. First, link the ContraLog Mini library to your project. In the video reviewing the ContraLog Mini board support package, we explain how to link our library to your project, in case you don't know how to do it. Then go to the folder containing our example projects and select the example named Read Modbus Send LoRa.cpp. Copy the code and paste it into your project's main.cpp file. In the void loop, you'll find code in which we establish the structure to execute the Modbus tasks of the ContraLog Mini, where we define the address of the Modbus slave sensor, which, in our case, is address 1, and which is predefined by the sensor. As we intend to perform only the reading of the values sensed by the device, we assign the function code 3 for devices using the Modbus RTU protocol, which indicates that we are going to read a holding register. The address of the initial register to be read is indicated, which, for us, is 1. The number of registers to be read is established, which, in our case, will be only 1. And a Modbus telegram is sent, and we wait for the slave's response, where its validity is verified and the data received is stored to be sent to the LoRaWAN network cloud. In this example, it will be possible to visualize the data frame collected from the sensor, which is composed of the slave address values, the Modbus function code, the number of elements of the sensor register, the data of the measurements taken by the sensor, and the value of the cyclic redundancy check. Likewise, the code also limits the sensor reading on a second-by-second basis, and this can be identified by the flashing of the RGB LED and purple at each sample taken by the sensor. Additionally, the communication_task function of the comms class is called, which handles sending the data of the sensor readings using the desired communication technology, in this case, LoRaWAN. When going through this function, you will find that a state machine is used to manage the device's communication tasks, controlling the state of the modules, Wi-Fi, LoRa, and Sigfox, and their transition between different phases. In module init, the module is initialized and, depending on whether it is Wi-Fi, it opens a captive portal or shuts down to go into standby. In standby, the device waits to send or receive data, and if necessary, goes to the storing task to prepare the data. Then, in joining, it tries to join the corresponding network, and if it is LoRa, it goes to waiting to join to wait for connection confirmation, retrying if it fails up to 10 times. In sending, the data are transmitted and a response is expected in receiving, where the confirmations or downlink messages are verified. Finally, if it is in Wi-Fi AP mode, the Wi-Fi gateway is managed and closed once the timer has expired. You will find this function in the source file of the ContraLog Mini library as communications.cpp, and we recommend that you analyze this part of the code to get more details of its operation. Before running the code, you need to prepare the data to be sent and specify the wireless communication technology you'll use. For that, first go to the source file of the ContraLog Mini library, communications.cpp, and locate the function prepare data to send. There, the structure of the message to be sent from the ContraLog Mini to the cloud server of the communication technology is indicated. This structure is defined by an uplink message of 12 bytes, where each byte is assigned a respective label, such as byte 0 is to indicate the type of alarm assigned. Bytes 1 and 2 are assigned for the data read by the sensor connected to the analog digital input 1. Bytes 3 and 4 are assigned for the data read by the sensor connected to the analog digital input 2. Bytes 5, 6, 7, 9, and 10 do not contain information and can be used if required by the user. In addition, byte 8 is assigned for the input DC voltage measurement reading, and byte 11 indicates the output 1 and 2 status. Likewise, you will find, within this function, a base structure that adjusts the possible data to be added in the uplink message to the LoRaWAN cloud server, in this case, It will only be necessary to enable the code that allows to set the information read by the sensor connected by the Modbus RTU protocol, where the sensor reading data, stored in bytes 3 and 4 of the Modbus registers array. Now, go to the EEPROM especially H file, which you will find in the header files folder of our library, and set a value in the EEPROM version each time you are going to alter any of the parameters that are housed within this function. Locate yourself in the array called initial params and make sure that the communication module type is set to LoRa technology, and define the radio frequency band for transmission, which in this case is the US 915 band. With these settings, you can now run your program and check your sensor reading through the serial monitor and verify that the message you have prepared is transmitted over the LoRaWAN network. In our case, the ContraLog Mini is linked to the ThingStack LoRa backend, where we can verify the reception of the message sent from our ContraLog Mini, where it is expected that we only see in the cloud server the bytes corresponding to the information collected by the sensor, and that have been added to the second and third byte of the uplink message. We cover how to link your ContraLog Mini to the ThingStack in a separate video. And that's it. You have successfully learned how to read a sensor using the Modbus RTU communication protocol and send the data to the cloud using LoRaWAN wireless communication technology. Make sure to follow our channels to learn more about the ContraLog Mini. Follow our other videos and discover more about Omicron IoT solutions, our devices, and how to impact your business and industry through the IoT.